Okay guys, so today we are going to be starting to graph. We're going to start with the trig functions that we've just learned about last week, and we're going to learn two new parent functions today. We're going to look at y equals the sine of x and y equals the cosine of x. Now, whenever you're graphing these trig functions, you can actually do them in either degrees or radians, so we're going to look at both. But the very first one we're going to start off with is the parent function y equals the sine of x, and we're going to be graphing that in degrees, just because it's a little simpler to see. So in order to figure out what this graph is going to look like, the first thing I'm going to do is I'm going to plot some points, and I'm going to plot some of the easy points to find. So if I start at 0 degrees, if I plug in 0 for x, I know the sine of 0 is 0. Then I'm going to pick another easy value to plot, and an easy value to plot would be at 90 degrees. At 90 degrees, I get a sine value of 1. Then if I go to 180, the sine of 180 is 0. The sine of 270 is negative 1. The sine of 360 is back to 0. Then I'm going to add a few more points. If I go another 90 degrees, if I went to 450, 450 is coterminal to 90, so the sine of 450 degrees would be 1. If I went backwards to a negative 90 is equivalent to 270, and the sine of 270 is negative 1. So that gives me just a few more points to plot. So I'm going to put those points on my graph. I'm going to mark my y-axis first. The highest I go is 1. The lowest I go is negative 1. And then I'm going to mark my x-axis with a few of the points we just did. So I started with negative 90, 90, 180, 270, 360, and 450. And then I'm just going to plot those points that I have right there. So the first one, negative 90 is at negative 1, 0, 0, 91, 180, 0, 270, negative 1, 360, 0, and 451. So you guys can kind of start to see a pattern here. I'm going from low to middle to high, and then back down again. So the only other thing you guys need to know about this graph is how I connect these points. Now, we didn't plot any of the in-between points, but if we did plot a lot of those, you would see these actually aren't going in straight lines to each point. It's actually going to curve as I go towards each one, like a wave. And we're going to look at more of the reason why that is later on this week. So this is my sine graph parent function. And if you look, it's going in that wave pattern. Okay, so we're going to look at this on the calculator so that you guys can see just what it looks like if I change a few things on there. So I'm going to go to my calculator. Okay, so I'm going to graph the function y equals the sine of x. And I'm going to go to my window. So the graph I just plotted went to negative 90. I want to see a little bit more of this graph, so I'm going to make that negative 360. And I'm going to make my x max 360. I'm going to try to get that pop-up to go away. And then I'm going to go to my y min. So the lowest y value I graphed was negative 1. The highest y value I graphed was positive 1. So I'm going to plot both of those. And then I'm going to look at my graph. So you guys can see, there's my wave. Okay, let's say I want to see more of this graph. If I make my x max a little bit bigger. Okay, and my x min a little bit bigger. I'm going to go to my window, and I'm going to make that negative 720 this time. And I'm going to go to a positive 720. So with more x's, you can see this graph just repeats itself more frequently. So we're going to learn a few new vocab words with this. The first one is cycle. So the cycle on the graph is basically a section of that graph before it repeats itself. So if I look back, let's look back at the picture I had. Okay, so the cycle would be from 0 until it repeats itself fully. So it starts to repeat itself fully at 360. So a cycle is a section of the graph before repeating. So another new vocab word we need to look at here is period. So the period is basically how many degrees or radians it takes to complete a cycle. So you won't ever need to find a cycle, but you're going to see that word basically in your directions. It'll tell you, because these functions repeat over and over and over again, in order to know how much of the graph to actually draw, it would say draw 1 cycle of the sine graph, or draw 2 full cycles, just so you know about how much to draw. So the period is the number of degrees or radians to complete a cycle. So on this graph here that I drew, my parent function, the period of my parent function is 360 degrees. Alright, so the last two things I want to look at are the domain and range. So the domain of the sine wave, if this graph were to continue on, every x value would be possible. So my domain in this case would be all real numbers. My range, on the other hand, is restricted. My range never is less than -1, and it's never more than +1. And we talked a little bit about why that was last week whenever we're doing those functions. So this is your sine parent function. All right, so now we're going to move on and we're going to do the cosine graph. And we're going to do the cosine graph with radians. So we can see get a little bit of practice doing that. All right. So my cosine graph, again, in order to graph this, I'm going to start off with picking some simple x and y values. So a simple x value would be 0, and the cosine of 0 is 1. Alright, and radians, an easy value equivalent to 90 degrees, is pi over 2, and the cosine of pi over 2 is 0, followed by pi. The cosine of pi is -1. 3 pi over 2 puts me at 0, and then 2 pi brings me back to 1. Okay, so now I'm going to go ahead and graph these points. So at 0 degrees, I'm at a value of 1. At pi over 2 radians, I am at a value of 0. At pi, I'm at -1. 3 pi over 2 is 0, and 2 pi is 1. And then we know from our previous wave that this graph is going to continue in that same pattern. So I'm going to add 2 more dots on there, just so I can see a little bit more of my graph. So again, we have a wave. So you guys can see a few similarities and a few differences between the sine graph. So one thing I do want to look at that's similar, the period of this graph is 2 pi. And we know that 2 pi is equivalent to 360 degrees. Now a new word that I want to look at is amplitude. So what the amplitude is the distance from the middle to the top or bottom of my graph. So if you look, we plotted some middle points, some high points, and some low points. All right, and then the y value from basically from all those middle points to those top points is going to be our amplitude. And it could be to the high or low because it's in the middle, so it could be either one. Okay, so if I look at this graph, if I look at my top and my middle, that distance in between there is the amplitude, and the amplitude of my parent function is 1. So the last new vocab word we have to look on here is the sinusoidal axis. So all these that we just graphed, these are sinusoids. Okay, they are waves. Now the sinusoidal axis is the axis that goes through my middle points. In this case, it is my x-axis. It's not always going to be the x-axis, however, and we're going to see that later on where it's going to start to change. Okay, but the sinusoidal axis goes through the middle points. And again, we're plotting those high points, those middle points, and those low points. Those are just kind of our guide and kind of gives us an outline of what this graph's actually going to look like. So there's our cosine parent function. All right, so some similarities are the domain and the range. It's in a wave as well, but one of the big differences, if you notice, at 0, the cosine graph's actually at the top of the wave, whereas in the sine function, it started at the middle of my graph. So that is one major difference we're going to look at once we start doing shifts later on next week. All right, so now we're going to move on, and we're going to start to look at a few changes to my graph. So the first graph I want to look at is going to be the graph of y equals 4 sine theta. So in order to figure out what this looks like, again, I'm going to start this off the same way. Now once we get used to seeing these changes, we can do it in different ways, but I want you guys to kind of see where this comes from. So I'm going to pick some easy theta values, such as 0, 90, 180, 270, and 360. So at 0 degrees, if I plug in 0, that's 4 times the sine of 0. So that is 4 times 0, which is still 0. 4 times the sine of 90, that's 4 times 1, which is a value of 4. 4 times the sine of 180 is 4 times 0, which is a value of 0. 4 times 270 is 4 times the sine of 270 is 4 times negative 1, which gives me a negative 4. And then 4 times 360 is 4 times 0 again, which still gives me a value of 0. So I can still graph this function. And then my difference here, my lowest and my highest values, are no longer at 1, now they're at 4. So when I plug in these points, what's going to change here is actually the amplitude. So there's one cycle of my sine wave. Okay, so if I look at this one cycle, my period is still 360 degrees. That didn't change for my parent function. What did change, however, is my amplitude. So my amplitude is now 4. Now what's going to make this really simple, if you look at my original function, that 4 is out in front. That's where my amplitude is coming from. If you guys think back to when you did transformations in Algebra 2, if you had a number multiplied on the outside, like 4 f of x, that was a vertical stretch. And that's really essentially what we did with our graph. We just stretched it vertically. So in general, if you have a function in the form of y equals a times the sine of x, or y equals a times the cosine of x, it's really, really simple to find my altitude, or my amplitude, because my amplitude is just that value of a that's written out in front. So that number in front just affects my amplitude. All right, so now we're going to look at what happens if I change the period. So we're going to move on to a new example. We're going to graph the function y equals the cosine of 3 theta. And we'll see what that does to our graph. And again, we're going to start off just by plugging in some basic points. I'm still going to stay in degrees for this one, and I'm going to use 0, 90, 180, 270, and 360. And actually, I'm thinking of a different example, so we're going to change those. Actually, those will still give me some correct values, but I want to pick some simpler ones to see more of this graph. So I'm going to start with 0, okay? If I want the cosine of 3 times 0, that's the same thing as the cosine of 0. And we already figured out the cosine of 0 is 1. The next value I'm going to pick, actually, instead of jumping all the way to 90, I'm going to pick 30. And the reason for that, when I plug that in, that's the cosine of 3 times 30. And 3 times 30 is 90. So I'm still finding the cosine of 90 as an answer, which we know is 0. Okay, so the next value I'm going to pick is 60. because that's the same as finding the cosine of 180, which I know is -1. Then I'm going to pick 120. Oops, I'm skipping one again. I'm going to pick 90, because that's going to be the same as the cosine of 270, which gives me 0. And then for my last one, I'm going to pick 120, which gives me the cosine of 360, which puts me back at 1. So now I still have a range from -1 to 1. Those are my highest points. But what's different now is these little marks that I'm making are closer together. I'm at 30, 60, 90, and 120. So when I graph this time, I still have a wave, I still have an amplitude of 1, but what's changed is if I look at one cycle of my graph. One cycle of my graph goes from 0 until 120. So that means that the period is 120 degrees now. Alright, what we also want to look at is how often I'm making those marks. Alright, so those marks are called my critical points. I have the high points, the middle points, and the low points. Those are my critical points. They're the guide that you get in order to graph this. So I mark those critical points every 30 degrees on this example. So what we're going to look at is just figuring out where these numbers come from based on my example, or based on my equation. So if you think back to your very first example that we did, okay, the original parent function had a period of 360 degrees, and this example has a period of 120 degrees. Now if you look again, we have that 3 on the inside. To go from 360 to 120, I just divide by 3. So in order to find my period, let's say I have a function in the form of y equals sine times b of x, or y equals cosine times b of x. Then in order to find my period is 360 divided by b. Or if I'm in radians, then my period is 2 pi divided by b. Alright, then to figure out how often I get my critical points, okay, when my period was 360, if you look back at your original function, when my period was 360, my critical points were every 90 degrees. But here, my critical points are every 30 degrees. And if you look in both of those cases, what I had to do was I took my period and I divided it by 4. I'm going to move that away from the watermark. So my critical points, to find how often I put them, it's the period divided by 4. So what we're going to look at now is we're going to look at an example that actually includes both of these transformations, and we're going to try and graph this without plotting points, just so we can get used to these different transformations that we see. So the next example we're going to do is we are going to graph 2 cycles of the function y equals 8 sine 1/2 x, y equals 8 sine 1/2 x, and we're going to graph this in radians, and I'm going to move these up a little bit. Okay, so in order to figure this out, in order to graph this, I'm going to look at those 3 things we just talked about based on my parent function. So if I look at this function I'm given, the amplitude we talked about was the number in front. So that 8 out in front is going to be my amplitude. Alright, we talked about how the period is 360 divided by b, or if we're in radians, the period is 2 pi divided by b. And in this case, my b is 1/2. So what I'm going to do is I'm going to do 2 pi divided by 1/2. And when I divide by fractions, what I do is I flip the second and I multiply. So this is actually 2 pi times 2 over 1, which gives me a period of 4 pi. And then finally, I'm going to see how often I make my critical points. And my critical points we determined was my period divided by 4. So I'm going to have a critical point every pi. So now I have all the information I need in order to graph this. The only other thing I need to double check on is what kind of a graph this is. Okay, so if I look, this is a sine graph. And if you remember, sine graphs started in the middle, and then they went up, then they went back to the middle, and then they went to the bottom, and then back to the middle. That was the pattern of my sine graph. So what I'm going to do is I'm going to mark my y-axis first. The amplitude is 8, so the highest my graph is going to go is 8. The lowest my graph is going to go is -8. And then the very first point I'm going to plot is going to be in the middle because it's a sine graph. I'm going to have a critical point every pi. So my next point after the middle, I go to high. So my next point will be pi away from that, which is 1 pi. Followed by 2 pi. Followed by 3 pi. And 4 pi. We'll just graph those for right now to look at. So if I start here, my very first point's mid, and then high, and then mid, and then low, and then back to mid. And that is one cycle of my graph. So the next thing I need, it tells me in the original directions to graph 2 cycles. So I need to continue this graph. I can either continue to the left and go negative or continue to the right. It is completely up to you guys. But I'm going to continue this one to the right. These are little easy values to count by. So after 4 pi, I'll be at 5 pi, 6 pi, 7 pi, and finally 8 pi before I complete my second cycle. Let me extend that line a little bit. So now I'm going to finish filling in my graph. It goes from middle to high, to middle to low, and back to middle. I'm going to connect my dots. There's 1 cycle, and there's 2 cycles. So there are 2 cycles of my sine wave. All right, so there's one last example we're going to look at. If you're still having trouble, we're going to do another graph with both transformations, and again, we're going to look at it in radians. So for the last example, we are going to look at the graph of 2 cosine pi over 4x radian, and we're going to do this one in radians. But I'm going to do it the same way. I'm going to find those things I just talked about. The first thing I want to find is the amplitude, the number in front, my A. My A is 2. So that means the highest point on my graph is 2. The lowest point on my graph is -2. After that, I'm going to determine what the period is. I can't just look at my graph and say the period is pi over 4. Remember, to find the period in radians, it's 2 pi divided by b. And in this case, my b is pi over 4. So my period is 2 pi divided by pi over 4. And when you're dividing fractions, you flip the second and multiply. So this is times 4 over pi. And when I multiply across, that's 2 pi over 1. That gives me 8 pi over pi, which means my period is just 8. So finally, once I know my period, I know how often I make my critical points. And I'm going to have a critical point at my period divided by 4, which is 8 divided by 4. So at every 2, I will have either a high, middle, or low point. And then the last thing, this is a cosine graph. So what's different between cosine and sine? Cosine, the first mark I make is high, and then I go to the middle, low, mid, and then back to high. So on cosine, the first one is a high point. So I already marked my y-axis. Now I'm going to go and I'm going to mark my x-axis. So I start at 0, and then every 2. So 2, 4, 6, 8, 10, 12, 14, 16. And again, if I want to go negative, I could. Let's go to -2, -4, -6, and -8. Now I'm actually going to graph my function. So at 0, I'm going to start, because it's cosine, I'll have a high point, mid, low, mid, high, and I'm going to continue to follow that pattern. And if I want to continue the other direction, it would look the same way. I would just keep plotting those points. So here, I'm missing most of the dots, and it's not very pretty, but that is what a cosine wave will look like. And this is kind of long, I know, guys, but this is the basics of how to graph sinusoidal functions. And that is all.